If I told you there's a crop that produces 50,000 pounds of food per acre while potatoes yield 15,000, that contains 15 to 20% protein while potatoes have 2%, that thrives in swamps, deserts, and mountains simultaneously, and that a single planting produces food for 30 years without replanting, you'd call me a liar. But I'm not lying. I'm describing a plant that fed the largest empire in human history. A crop so productive that Spanish conquistadors couldn't believe the yields they were witnessing. A tuber so versatile that NASA spent $6 million researching it for space colonies in the 1980s. Then mysteriously shut down the program and destroyed the research. This plant could have revolutionized American agriculture. Instead, it was systematically removed from agricultural universities, seed catalogs, and the American consciousness within one generation. Today, if you walk into any garden center in America and ask for this plant, they will look at you like you're speaking a dead language. And maybe you are, because the suppression was so complete that most Americans under 50 have never heard its name. If you're starting to realize that the plants we're told to grow are not the plants that feed us best, hit subscribe, and comment below if you've ever heard of OCA, the lost potato of the Andes, because I need to know if the burial was total or if the knowledge survived in pockets. Welcome to Ancestral Yields. If you're ready to stop growing what Big Ag wants you to buy and start growing what actually feeds your family, make sure to like this video. What I'm about to show you will change how you think about root vegetables forever. The plant is OCA, Oxalis tuberosa, and before the potato reached Europe, before the Yukon Gold or the russet existed in Western consciousness, OCA was feeding millions across an empire that stretched 2,500 miles. The Inca Empire, the largest empire in pre-Columbian Americas, was built on three foundation crops: quinoa for protein and grain, maize for carbohydrates, and OCA for dense, storable energy. But OCA wasn't just food, it was engineering. At 8,000 years old, OCA is one of the most ancient domesticated crops in the world. Archaeological evidence places its cultivation in the Andean highlands of Peru and Bolivia as far back as 6000 BC. The indigenous peoples of the Andes didn't just find OCA growing wild and decide to eat it. They selected it, bred it, and refined it over millennia into a crop so diverse that over 50 distinct varieties existed by the time the Spanish arrived. These varieties ranged in color from bright yellow to deep purple, from orange to red to white with pink stripes. Each variety was adapted to specific microclimates, specific altitudes, specific soil types. The Inca weren't gardeners. They were geneticists. OCA thrived where other crops failed, at altitudes above 10,000 feet, where the air is thin and frost strikes 9 months of the year. OCA produced abundantly. The tubers grow underground, protected from hail and wind. The plant tolerates poor soil, requires no fertilizer, and needs minimal water once established. For the Inca, OCA was insurance. When maize failed due to drought, OCA survived. When potatoes were struck by blight, OCA persisted. It was the crop you planted when you needed certainty. But OCA offered something else the Inca prized: storage. The tubers could be freeze-dried using a traditional method called chuño. Farmers would spread the freshly harvested OCA on the ground during freezing nights. The tubers would freeze solid. During the day, the sun would thaw them. Farmers would then walk on the tubers, pressing out the moisture. This cycle repeated for several days until the tubers were completely dehydrated. Once dried, OCA could be stored for years without refrigeration, without spoilage, without loss of nutrition. The Inca built granaries the size of warehouses to store chuño. These granaries fed armies, sustained cities during sieges, and kept populations alive during crop failures. OCA wasn't just food, it was infrastructure. When the Spanish arrived in 1532, they were stunned by what they found. Francisco Pizarro's men documented vast agricultural terraces carved into mountains, irrigated by stone aqueducts, planted with crops the Spanish had never seen. They wrote about OCA extensively. They described the tubers as sweet, tangy, and incredibly abundant. The Spanish recognized the caloric value immediately, but they made a decision that would alter history. The Spanish chose the potato, not because the potato was superior, but because the potato was familiar. Potatoes resembled European tubers. They were bland, starchy, and easy to incorporate into European cuisine. OCA, on the other hand, was strange. It had a sharp, lemony flavor due to oxalic acid. It came in bizarre colors. It didn't cook like a potato. So the Spanish brought potatoes back to Europe and left OCA in the Andes. This decision had consequences. By the 18th century, the potato had become a staple across Europe. Ireland's population exploded because potatoes were so productive. But potatoes have a fatal weakness. They are genetically uniform and vulnerable to disease. In 1845, a single pathogen, Phytophthora infestans, wiped out Ireland's potato crop. 1 million people starved to death. Another million fled the country. The Irish potato famine was a direct result of monoculture dependence on a single, vulnerable crop. OCA wouldn't have failed like this. OCA has extraordinary genetic diversity. The 50-plus varieties cultivated by the Inca meant that if one variety succumbed to disease, others survived. OCA also contains compounds that make it naturally pest and disease resistant. It doesn't suffer from late blight. It doesn't attract potato beetles. It simply grows, year after year, in conditions that would destroy a potato crop. But Europe never knew this because OCA never left South America in significant quantities. The Spanish made their choice, and OCA was forgotten. For 3 centuries, OCA remained a regional crop, grown by indigenous farmers in the Andes and nowhere else. Then in the 1970s, something changed. The global food crisis of the early 1970s forced governments to seek alternative crops. The United Nations and various agricultural research institutions began studying underutilized Andean crops. OCA was identified as a high-potential candidate. Research programs were established in New Zealand, Mexico, and the United States. In New Zealand, OCA thrived. The cool, temperate climate was perfect. By the 1990s, New Zealand farmers were growing OCA commercially, selling it in supermarkets as New Zealand yams. The crop became a boutique success. But in the United States, the research took a different turn. In 1985, NASA's Controlled Ecological Life Support System program, designed to develop crops for long-duration space missions, identified OCA as an ideal candidate. The reasoning was clear. OCA produces high yields in small spaces, requires minimal inputs, tolerates environmental stress, and provides dense nutrition. NASA funded a comprehensive research program at several land-grant universities. Scientists grew OCA in controlled environments, analyzed its nutritional profile, tested its growth under artificial light, and developed propagation protocols. The results were extraordinary. OCA outperformed potatoes in almost every metric relevant to space agriculture. Higher protein content, better nutrient density, more efficient use of water, and superior storage characteristics. The research was compiled into detailed reports. NASA planned to include OCA in its crop rotation systems for future Mars missions. Then in 1991, the program was shut down. Funding was cut. The research was archived and never published in mainstream agricultural journals. The seed stock maintained for the trials was discarded. Scientists involved were reassigned to other projects. Within 5 years, OCA had vanished from American agricultural research. No official explanation was given. The program simply ended. Why? Because OCA threatened the potato industry. By the 1990s, potatoes were a $4 billion industry in the United States. Seed potato companies, fertilizer manufacturers, pesticide producers, and industrial farming operations were all economically dependent on potato monoculture. OCA, with its disease resistance, low input requirements, and perennial growth habit in mild climates, would disrupt this entire system. OCA requires no synthetic fertilizer. It fixes some of its own nitrogen and thrives in poor soil. If farmers switched to OCA, fertilizer sales would drop. OCA is resistant to most pests and diseases that plague potatoes. If farmers grew OCA, pesticide sales would collapse. And in USDA zones 8 through 11, OCA is a perennial. Plant it once, harvest for years. If farmers adopted perennial OCA, annual seed potato sales would plummet. The combined economic threat was massive. The potato industry couldn't allow OCA to gain a foothold. So the research was buried, the knowledge suppressed, and OCA was forgotten. But OCA didn't disappear globally. In the Andes, it remained a staple. In New Zealand, it became a specialty crop. In the UK, a few small farms began growing it. The knowledge survived in pockets. And now, Gardeners and small-scale farmers are rediscovering what NASA knew. OCA is one of the most productive, nutritious, and resilient crops on Earth. Let me show you the data. OCA tubers are 15 to 20% protein by fresh weight. Potatoes are 2%. OCA contains approximately 3 to 4 grams of protein per 100 grams of tuber. That's double the protein of a potato and approaching the protein density of beans. For a root vegetable, this is extraordinary. OCA is also rich in vitamin C, providing 30 to 40 milligrams per 100 grams. That's comparable to an orange. The tubers are high in potassium, magnesium, and iron. And if you grow the purple or red varieties, you're getting massive doses of anthocyanins, the same antioxidants found in blueberries. The yield is staggering. In optimal conditions, OCA produces 50,000 pounds per acre. Potatoes, in comparison, yield 15,000 to 20,000 pounds per acre. That's more than double the yield. And OCA achieves this without fertilizer, without pesticides, and with minimal water. The plant is a biological miracle. OCA also has a unique flavor profile. The tubers contain oxalic acid, which gives them a tangy, slightly lemony taste. This acidity decreases if the tubers are exposed to sunlight for a few days after harvest, a process called sweetening. Once sweetened, OCA tastes like a cross between a potato and a tart apple, with a creamy texture when cooked. You can roast them, boil them, mash them, fry them, or eat them raw in salads. The versatility is unmatched. But there's a catch. OCA has a day-length sensitivity that makes it challenging to grow in some climates. OCA is a short-day plant. It only begins forming tubers when the day length drops below 12 hours. In equatorial regions and in the Andes, this happens year-round or predictably. But in temperate regions, this means OCA doesn't start producing tubers until late summer or early fall. In areas with early frosts, this can be a problem. The tubers don't have time to fully develop before freezing temperatures kill the plant. This day-length sensitivity is why OCA struggled to gain traction in North America and Europe historically. Farmers planted it, waited all summer, and then watched frost kill the plant just as tubers were forming. The yields were disappointing. The crop was abandoned. But this problem is solvable. Breeders in New Zealand and the UK have developed day-neutral varieties that form tubers regardless of day length. These varieties, like Sunset and Golden Nugget, produce tubers throughout the growing season, allowing for harvest before frost in temperate climates. These varieties are the key to growing OCA successfully outside the tropics. So how do you grow it? First, you need to source tubers. OCA is not grown from seed in practical terms. It's propagated from tubers. Just like potatoes, you can order OCA tubers from specialty suppliers. In the United States, companies like Cultivariable and Peaceful Valley Farm Supply occasionally stock them. In the UK, Real Seeds and the Seed Collection carry OCA. In New Zealand, it's available at some garden centers. Expect to pay $5 to $10 per pound. You'll need about 1 pound to plant 10 to 15 plants. Plant OCA in spring after the last frost. The tubers are frost sensitive and will rot in cold, wet soil. Wait until the soil temperature reaches at least 50 degrees Fahrenheit. Plant tubers 2 to 4 inches deep, spaced 12 inches apart in rows 18 inches apart. OCA grows into a sprawling plant, 12 to 18 inches tall, with clover-like leaves and small yellow flowers. The plant needs full sun and well-drained soil. OCA tolerates poor soil but performs best in loose, slightly acidic soil with a pH of 5 to 6. 5. Do not add nitrogen fertilizer. Excess nitrogen causes the plant to produce lush foliage and few tubers. OCA is a light feeder. Compost or aged manure is sufficient. Water regularly until the plant is established, then reduce watering. OCA is drought tolerant once mature. Overwatering causes tubers to rot. In most climates, natural rainfall is adequate. The plant grows slowly at first. Don't be alarmed. OCA puts energy into root development before producing foliage. By midsummer, the plant will be bushy and vigorous. In late summer, as days shorten, tubers begin forming. You won't see them because they're underground. Be patient. In temperate climates, harvest OCA after the first light frost kills the foliage. The frost signals the plant to stop growing and directs all energy into the tubers. Wait 1 to 2 weeks after frost. Then dig carefully. The tubers form in clusters around the base of the plant, similar to potatoes but closer to the surface. Use a garden fork, not a spade, to avoid cutting the tubers. In USDA zones 8 through 11, where frost is rare or absent, OCA behaves as a perennial. You can harvest some tubers and leave some in the ground. The remaining tubers will sprout and produce new plants the following year. This perennial habit is OCA's ultimate advantage. 1. Planting. Years of harvests. Once harvested, handle the tubers gently. The skin is thin and bruises easily. Brush off excess soil but don't wash them until you're ready to use them. Store OCA in a cool, dark, dry place. They keep for several months under proper conditions. Before cooking, expose the tubers to sunlight for 3 to 5 days. This reduces the oxalic acid content and sweetens the flavor. After sweetening, OCA is ready to cook. Roast them like potatoes. Boil and mash them. Add them to stews, or slice them thin and fry them into chips. The flavor is unique, tangy, slightly sweet, and incredibly satisfying. There is one safety consideration. OCA contains oxalic acid, the same compound found in spinach and rhubarb. In large quantities, oxalic acid can interfere with calcium absorption and may contribute to kidney stones in susceptible individuals. However, the levels in OCA are low, especially after the sweetening process. For most people, OCA is perfectly safe to eat regularly. If you have a history of kidney stones, consume OCA in moderation and ensure you're getting adequate calcium in your diet. Now let me tell you what growing OCA represents. This isn't just about planting a weird tuber from South America. This is about reclaiming food sovereignty. Every OCA plant you grow is one less dependency on industrial agriculture. It's one less purchase of chemical fertilizers. It's one less sale for pesticide companies. It's one less contribution to the monoculture system that has destroyed soil, health, and concentrated food production into the hands of a few corporations. OCA is a direct challenge to the narrative that we need industrial agriculture to feed the world. OCA proves that high-yielding, nutritious, resilient crops exist, but they've been suppressed because they don't generate profit for input suppliers. The potato industry thrives on selling certified seed potatoes every year, selling fertilizers to boost yields, and selling fungicides to fight diseases that wouldn't exist in a diverse system. OCA doesn't need any of that, it just grows. And this is why you've never heard of OCA. Not because it doesn't work, not because it doesn't taste good, not because it's hard to grow, but because knowing about OCA makes you independent, and independent growers are not profitable customers. Here's what you do next. Source OCA tubers. Plant them this spring. Grow them. Learn what works in your specific climate. Save tubers from your harvest to replant next year. Share tubers with friends and neighbors. Build a network of OCA growers. Create a seed bank that exists outside corporate control. Second, educate yourself on other suppressed crops. OCA is not alone. There are dozens of high-performing, nutrient-dense crops that have been systematically removed from Western agriculture because they threaten industrial profits. Start researching. Start experimenting. Start growing. Third, question everything you've been told about what you should grow. The vegetables in seed catalogs are there because they're profitable to sell, not because they're the best options for your soil, your climate, or your nutrition. The crops we've been taught to grow are the crops that keep us dependent. The crops we've forgotten are the crops that set us free. OCA is proof that the agricultural system is designed not to feed us best, but to profit most. And once you see that, you can't unsee it. So grow OCA. Taste what the Inca knew. Harvest what NASA tried to hide. And remember, the best crops are the ones they don't want you to know about. If this opened your eyes to what's been hidden, hit subscribe. We're going to keep digging up the crops they buried. We'll see you in the garden.